So if you're working on Project 6, one of the things you get to do for that project is implement a parser. We've got some descriptions in the write-up, and the starter code has a lot of code to get you started writing the parser. But I wanted to add another example to explain how the parser is supposed to work and sort of walk you through how it might handle a particular expression. So I put together this little presentation. Here's what I'm going to be trying to show in it, so I thought I would first explain that and then walk through how this example might get parsed. So up in the upper left, I've got a picture of the regular expression we're going to be parsing. It's in this expression, I tried to show everything that we have to be able to handle. There's, well, at least an example of it. So there's concatenation, there's some literal expressions, there's repetition, and there's the alternation pattern, this vertical bar in the middle. So up here we'll talk about what parts of that expression are getting parsed at different points. Over on the left, I've drawn the same picture of the functions in the parser, same one as in the assignment, same ones as in the starter. So parse alternation is for handling sort of the lowest precedence stuff, and then it can call parse concatenation and parse repetition all the way down to parsing the highest precedence stuff, or the sort of the smallest bits of a regular expression. Over on the right, that's a picture of the parse tree we're going to be building. So as we parse the expression and as we go around between these functions, I'll fill in parts of that tree the way I would expect the parser to instantiate them as it made sense of the expression. So this is kind of what it's going to look like at the end. At the start, we'll have the whole expression like I've drawn up there. We'll call the parser and we'll pass in the expression. And at the start, it hasn't parsed any of it yet. We enter the parser through the parse alternation function, and its job is to see if the expression has two smaller expressions glued together with a vertical bar. For parse alternation, even if it does have multiple expressions put together with a vertical bar, it's going to start with some expression on the left of that. So before it even sees that vertical bar in the middle, parse alternation is going to say, well, first, if there's a vertical bar, first let's parse the stuff on the left of it. So it's going to call parse concatenation. Same thing here. If there are two smaller expressions concatenated, first we have to get the expression that's on the left-hand side of that. So that guy's going to call parse repetition. And whether or not there's a repetition operator, there has to be some expression to the left of that. So the first thing parse repetition is going to do is call parse atomic pattern to say, well, let's see how this expression starts out. And parse atomic pattern is going to notice, oh, this starts with an A. That is an ordinary character, so in the regular expression, it's just supposed to match itself. So parse atomic pattern is going to go ahead and instantiate a literal pattern object, and I showed that over here. We finally got to part of the expression that we can go ahead and parse. And when it makes that literal pattern, that's going to be an object whose job it is to match that letter A at the start of the pattern. So you can see when I made an instance of literal pattern, it's got a pointer to a match and a destroy function, but I'm not showing those. Those get filled in when you call the constructor for that object, but it wouldn't really add anything, and it would make the figure a lot busier if I showed those pointing to something. So just be aware that those point to functions to match a literal expression. Inside the literal expression, it remembers, oh, I'm supposed to match the symbol A. And if you look up here in the upper left, I colored the A red to show at this point we've parsed that much of the expression. Parse atomic pattern saw that it starts with an A, and it made an instance of literal pattern to match that. And then it's going to return that to the caller, so we fall back to parse repetition. Parse repetition looks after the A, and it's looking for a plus or a question mark or a star to see if we're looking for repeated occurrences of A. It doesn't see that, so it says, well, this must not be a repetition pattern, so it falls back to concatenation. And concatenation notices, oh, looking ahead, this is two smaller patterns that are concatenated. So it's going to go ahead and make a pattern to match the concatenation of two smaller patterns. This is something that was given to you in the starter, and if you look at the starter, you'll see I made a little struct called a binary pattern that's for keeping up with a pattern that contains two smaller patterns. So I drew a little box there to show, well, we're going to instantiate a binary pattern that matches that A followed by whatever pattern comes after it. In the parser, it doesn't really make the binary pattern yet because it doesn't know, or it hasn't parsed what comes after the A. But I drew a little box there to show, well, parse concatenation knows it's going to make a pattern. It just needs to parse the next thing, the thing that's concatenated with the A. So it calls parse repetition. Parse repetition ends up calling parse atomic pattern, and that's where we parse the B. Just like we did with the A, parse atomic pattern notices, oh, B is an ordinary character, so it makes a literal pattern for that, and then it returns that. Again, that falls back to parse repetition. There's nothing, or at least there's no repetition character after the B, so that eventually falls all the way back to parse concatenation, and then we finally get to instantiate that binary pattern. And pretty much everything we've done so far is already provided for you in the starter. If you trace through how it behaves, it should do pretty much what we just talked through. Now parse concatenation looks after the B and says, that's not a concatenation with another character, so it's not my job to parse that. So it falls back to parse alternation. And there, parse alternation notices, oh, there's a vertical bar next in the string. That's my job. I'm supposed to handle I'm supposed to handle two smaller patterns glued together with a vertical bar. So it's going to make some kind of object to handle parsing either of the two patterns on either side of that vertical bar. It's not going to make it yet because it has to parse the rest of the expression, or it has to parse what comes after that vertical bar. So I did the same trick here. I drew a little dashed box to show, well, parse alternation is going to instantiate something to handle that alternation, the two patterns where it can match either of them. It just hasn't made it yet. It's going to parse what comes after that vertical bar. And here, kind of like in the assignment, you're going to have to create a pattern object that handles alternation, one that can match either of the patterns on either side of that vertical bar. This one's really easy to make, but I don't know how you're going to, I don't know what type names you're going to choose to make this. So I put a maybe in front of that. Maybe you're going to have a struct called alternation pattern, and maybe it's going to have a match function that does the job of matching an alternation. So I put a dash bar or a dash box there with maybe in front of it. However you do that, at this point the parser is going to parse what comes after the vertical bar so it can glue it together with the pattern that we've already parsed, the one that came before the vertical bar. So at this point, parse alternation is going to call parse concatenation, it's going to call parse repetition, that's going to call parse atomic pattern, and there parse atomic pattern is going to see that C character, and it's going to say that's an ordinary character. I'm going to make a literal pattern that can match that. Once it's done that, it falls back to parse repetition, and parse repetition is going to notice, oh, whatever pattern just got parsed, there's a plus after it, and that's one of our repetition characters. So I'm going to make a pattern object that can handle, well, in this case, one or more repetitions of C. Kind of like in the assignment, I don't know what struct you're going to make to handle this, but maybe you're going to make a struct called repetition pattern that does the job of matching one or more occurrences of the pattern, of the repeated pattern, in this case, C. So I called that repetition pattern with a maybe in front of it because it depends on how you're going to do that. And then once the repetition pattern has been made, it's going to fall back to parse concatenation. Parse concatenation doesn't see anything else in the pattern, so it's going to fall all the way back to parse alternation, and then finally we get to instantiate a pattern object of your choice, however you want to implement it, but a pattern object that's going to do the job of matching either the AB part of this pattern or the C plus part of this pattern. And this should match what we started with. Here we've sort of traced through what the parser would do, and as it instantiated this parse tree, we kind of talked through how that might get built. Hopefully this will help you as you're filling in these parser functions. They're all there in the starter, but you get to add some code to each of these functions. And I would suggest as you add support for new types of patterns, like maybe you're going to start with the dot pattern, go ahead and add code in the pattern file to support that new type of pattern, and then add the corresponding code to the parser to be able to recognize that type of pattern. I wouldn't try and do them all at once, but I'd kind of add them gradually, and hopefully each time you add support for a new type of pattern, you'll start passing some additional test cases. So good luck with that, and hopefully this little recording will help you out some.